Practical chemistry. Identification of gases CO2, SO2, H2S, NO2, H2, NH3, chlorine, hydrogen chloride. Carbon dioxide turns lime water milky but has no effect on potassium dichromate paper. Sulfur dioxide turns orange potassium dichromate paper green, turns pink potassium permanganate paper white. Nitrogen dioxide reddish brown gas. Hydrogen sulfide turns lead acetate paper black. Ammonia forms dense white fumes of ammonium chloride with a glass rod dipped in concentrated HCl. Chlorine gas turns moist blue litmus red and finally bleaches the paper. Turns starch iodide paper blue black. Identification of acid radicals. Carbonate, sulfite, sulfide, chloride, nitrogen, and sulfate. Heating effect on carbonate. Carbonate, zinc carbonate. Color of the residue yellow when hot, white when cold. Gas evolved. CO2 is produced, which turns lime water milky but has no effect on K2Cr2O7 paper. Copper carbonate. Color of the residue black residue. Heating effect on nitrate. Nitrate, zinc nitrate. Color of the residue yellow when hot, white when cold. Gas evolved brown gas. Copper nitrate. Color of the residue black residue. Gas evolved rekindles glowing splint. Lead nitrate. Color of the residue yellow residue. Action of dilute acid. Action of dilute acid on carbonate. Observation. Brisk effervescence. Gas evolved turns lime water milky but has no effect on K2Cr2O7 paper. Action of dilute acid on sulfite. Brisk effervescence. Gas evolved turns orange K2Cr2O7 paper green and pink KMNO4 paper white. Action of dilute acid on sulfide. Observation. Brisk effervescence. Gas evolved has rotten egg smell and turns lead acetate paper black. Identification of chloride, nitrate and sulfate. Acid radical chloride. Test. AgNO3 solution added to sample solution. Observation. White precipitate soluble in NH4OH, insoluble in HNO3. Acid radical sulfate. Test. Barium chloride solution added to sample solution. Observation. White precipitate. Acid radical nitrate. Test. Concentrated H2SO4 added to mixture of sample solution and FeSO4 solution. Observation. Brown ring at the junction of two liquids. Identification of basic radicals. Color of precipitates. Blue precipitate of copper hydroxide with little NaOH or NH4OH. Inky blue solution with excess NH4OH. Dirty green precipitate of FeOH whole twice with little NaOH or NH4OH. Reddish brown precipitate of FeOH whole thrice with little NaOH or NH4OH. Identification of basic radicals. Salt solution, basic radical. Copper sulfate solution, Cu2+. With little NaOH solution gives pale blue precipitate. With excess sodium hydroxide solution gives pale blue precipitate which remains insoluble. With little ammonium hydroxide solution gives pale blue precipitate. With excess ammonium hydroxide solution gives pale blue precipitate dissolves to form inky blue solution. Salt solution, FeSO4 solution, basic radical Fe2+. With little sodium hydroxide solution gives dirty green precipitate. With excess sodium hydroxide solution gives dirty green precipitate which remains insoluble. With little ammonium hydroxide solution gives dirty green precipitate. With excess ammonium hydroxide solution gives dirty green precipitate which remains insoluble. Salt solution, FeCl3 solution, basic radical Fe3+. with little NaOH solution gives reddish brown precipitate, with excess sodium hydroxide solution gives reddish brown precipitate which remains insoluble, with little ammonium hydroxide solution gives reddish brown precipitate, with excess ammonium hydroxide solution gives reddish brown precipitate which remains insoluble. Salt solution, basic radical, zinc sulfate solution, basic radical Zn2+, with little NaOH solution, gelatinous white precipitate observed, with excess NaOH solution, white precipitate dissolves forming colorless solution, with little NH4OH solution, gelatinous white precipitate, with excess NH4OH solution, white precipitate dissolves forming colorless solution. Salt solution, lead nitrate solution, basic radical Pb2+, with little sodium hydroxide solution, chalky white precipitate absorbed, with excess NaOH solution, white precipitate dissolves forming colorless solution, with little NH4OH solution, chalky white precipitate, with excess ammonium hydroxide solution, white precipitate which remains insoluble. Salt solution, calcium chloride, basic radical Ca2+, with little NaOH solution, chalky white precipitate, with excess NaOH solution, white precipitate remains insoluble, with little NH4OH solution, no precipitate, with excess NH4OH solution, no precipitate. To distinguish between CuO and MnO2, MnO2 evolves chlorine gas with treatment with concentrated HCl, whereas CuO does not evolve chlorine gas with concentrated HCl. CuO gradually dissolves in dilute hydrochloric acid to form a green solution, whereas manganese oxide does not dissolve in dilute hydrochloric acid. To distinguish between acid and alkali, alkali produces pale blue precipitate with copper sulfate solution, whereas acid produces no precipitate with copper sulfate solution. In the given diagram, it is observed that alkali reacts with CuSO4 solution producing pale blue precipitate, whereas acid reacts with CuSO4 solution giving a clear solution, that is no blue precipitate is observed.